Hello, today I'm going to be using Maple for a quick little guide of differential equations, of solving them, of creating a system of them, of creating graphs and diagrams of them, and it's fairly straightforward and really easy, and I'll show you. And now we need an equation, and so I'll create an equation with the colon equals, and let's just make it x squared plus x, something simple. And then we could check if equation 1 really did get fed that equation. Yep, there it is. And now we use our lovely command diff to find the differential equations. So we plug in equation 1 and doesn't work. So why did that happen? It's because we didn't say we're with respect to what we're differentiating. So we gotta actually format it EQ1 and then respect to x, and then there, now we get our differential. Alright, and I don't know if you noticed, but we're getting some really weird text outputs whenever we type in our commands. So what we're going to do to fix that is we're going to go to Tools, Options, Display, and our output we don't want as Maple notation, we want that as 2D math. We apply our session, and then if I type EQ1 again, it looks very nice. It's the way we want to do our math. Alright, and next what we want to do is solve a differential equation using Maple. And so the best way you could do that is by having a differential equation. So we'll set up EQ1 to be some arbitrary differential equation. Diff of, let's say the function is y of t with respect to t. And then let's say that's minus y. Oops, that's supposed to be minus, equals 2, something simple. And there, that is something you would normally see in your day-to-day math if you're still stuck in classes like I am. And now what we gotta do is we run the program, or the function dsolve. And we put in equation 1. And we put in the initial function. Oops, that's supposed to be 1. And there you go. That's your generalized answer right there. Next up, we can show initial conditions. So init cons. I just like using that name as a default for initial conditions. Let's say y at 0, so like the start, is 4. Okay, and now with dsolve, same function, we're going to have equation 1 and init cons with respect, or with the function y of t. There you go. So that plugged in the initial conditions into equation 1 and then solved it. So that's your answer for the exact initial conditions of y0 equals 4 for equation 1. Okay, and now we do something fancy by adding graphs into Maple. And so what we do with that is we have to use a package. We use with for entering in packages. I believe it's DE tools. Yeah, ooh. And then also you get every single, essentially, function that comes with that. Way to just minimize that is to add a colon at the end of that command. Puts it all away, but still runs it. And then now we can use de plot. We feed in equation 1, our differential equation, the form of it, which was y of t, and then we enter a range for t. So I'd say equals 0, and then 2 dots for range, and then we have to enter a range for y. About 5. And you could always change this. And then what else? Oh, we can add a color. Equals I guess red. I believe that's it. Yeah, and so now we get the subfields for it. The for all the solutions. And so obviously you can see here at -2, where our starting base is, everything either goes up and goes down from it. Then also a cool thing we could do is we can edit this to be containing our initial conditions. And so we could, in between all the special colors and tags at the end, we add initial conditions here, and since we already have them, init cons, and then we make the initial conditions its own separate color through its line color equals, and then we can actually make this a function of t, and so that'll be really helpful. Oh, well, since our initial condition is 4, it barely is on the graph anyways, so now we could change this to be 0.5. So that changes init cons, and then this will change it accordingly. And you can kind of see it's going from red to orange. I bet if I got it closer to -2, we could see more of it. Yeah, and obviously you can mess with this as much as you want. So 1.5, I'm just curious myself now. Yep, and now we're starting to see more of the picture of the initial condition and the solutions along it. And so yeah, this Maple is really helpful for visualizing and solving differential equations, and I hope you'll explore it as much as I have. I could probably spend hours doing this, but this is supposed to be 5 minutes, so have fun on your own, I guess. And I hope you have a good one.